Leonardo da Vinci once said that simplicity is the ultimate sophistication. Hi, my name is Stefan, and I'm with the SMMID group. The SMMID is a space multi-purpose medical imaging device. You might ask yourself, why SMMID? What is SMMID? One of the biggest problems on the International Space Station and in deep space missions is that general medical diagnoses currently require multiple tools in space. I mean, you could have a laryngoscope over here, you could have an ophthalmologoscope over there. What is an ophthalmologoscope anyway? The SMMID is the solution. The SMMID integrates existing medical imaging technology to make diagnoses easier in space. So here's our routine tackle of the SMMID. We divide it up into 3 groups: mechanics, medical imaging, and software. The mechanics, they tackled the outside portion of the hardware. So everything that you see out here. What they did is they went into CAD and they developed a PLA structure for different devices that are used to image different orifices of astronauts in space. Our medical imaging team then went in a little bit further and developed some cool gadgets. I'll get to the IR thermometer later, but first, the ENT scope. ENT stands for ear, nose, and throat. What doctors do when you go for a checkup is that they attach a cephalum to the device and then look at your ear, nose, and throat. We attach that to the device. We also attach a couple of other cool cameras to be used to image things like the eye, skin, and the mouth. I think the coolest thing on here is something called the IR thermometer. The IR thermometer is a little device that uses IR spectroscopy, which is basically electromagnetic radiation, to take temperatures of astronauts. It's really cool because you don't have to touch the astronaut. You can stand about 15 feet away and point this little gun at an astronaut and take the temperature of it. Digging a little bit deeper, our software team went in and developed something called our GUI. Our GUI is basically a software web-based platform that astronauts can use to go through tutorials, to take pictures of themselves, and then send it down to ground so that medical doctors down at flight surgery can help diagnose these problems. I'd like to thank my team, first of all. We had a lot of cool engineers. We had engineers from Germany, we had university researchers from Rice, and we also had a couple of NASA people help us with this. So it was a very collaborative effort. Before we get to questions, we want to show you a detailed calendar of what we're doing. So in 2014, we want to develop our first prototype using aluminum technology and go through different testing phases. After our testing phases, we want to certify for space, we want to optimize the final assembly, and then in 2015, launch it to the International Space Station. Questions?